This is Jacob's Algebra, Chapter 11, Lesson 4. The subject of Lesson 4 is more on addition and subtraction of fractions. But before I start that, I want to go over something that seems to have been an issue on the homework from Lessons 1, 2, and 3. When a problem says find the greatest common factor, like of 12x plus 3x squared, the greatest common factor there is going to be 3x. So if you're asked to find the greatest common factor, 3x is all you have to write. If, however, you are asked to factor 12x plus 3x squared, change that to a plus, you've got to write the greatest common factor and then what you multiply it by to get 12x plus 3x squared. So we would be multiplying it by 4 plus x. So if you're just asked for the greatest common factor, then you would write 3x. If you're asked for the greatest, if you're asked to factor it or factor it completely, then you find the greatest common factor first and you put that outside the parentheses and then you write down what you need to multiply it by to get what you started with. Now you might also have something like factor x squared plus 6x plus 5. And in that case, there isn't a greatest common factor. In that case, you have to factor it into two binomials, and it would be x plus 5 times x plus 1. There isn't a greatest common factor because there's no common factor. The common factor, I guess, would be 1. But you can factor x squared plus 6x plus 5. The other thing I noticed on the homeworks, especially from lesson 3, there were questions where it asked you to give the prime factorization of numbers. So if, for instance, you had 42x and you need to break that down into prime factors, well, 42 can be broken down into 6 times 7. 7 is a prime number, so you can go ahead and circle that. It's a prime number. You can't break that down any further. But 6 can be broken down further. 6 can be broken down into 3 times 2. Both of those are prime numbers. So 42 would be written as 2 times 3 times 7. So to write 42x, we would write 2 times 3 times 7 times x. Or if we had, for instance, 84, which we know is 2 times 42, 2 is a prime factor, we already know the 42 can be broken down into 2 times 3 times 7. Notice that we have 2 occurring twice, so this would be 2 squared times 3 times 7. So if you're asked to break something down into prime factors, you don't just give one of the prime factors. You don't just give the greatest prime factor or the largest number that you can get when the largest number from any pairs of factors that you can find. You have to break it down into prime factors. Find some pair of numbers that multiply to what you started with, and then break those down until you get down to prime numbers. Okay, so that's enough of the review part. Now we're going to start with the actual adding and subtracting with fractions. So we're going to go back first to something that you did probably in 5th or 6th grade, which is writing a mixed number as an improper fraction. Like let's say you had 4 3/5. How would you write that as just an improper fraction, as a fraction of 5? Well, you know what you need to do is you take your whole number 4 and you multiply it by the denominator, which is 5. 4 times 5 is 20, and then you add the numerator. So you would add 3. 20 plus 3 is 23. The reason that works is that 4 3/5 is really the same as 4 plus 3/5. We can't add these directly as they are because they don't have a common denominator. This 4 is really a fraction over 1. We need to have a common denominator of 5. So we need to multiply this first fraction by 5 over 5. When we do that, we end up with a common denominator of 5. 5 times 4 is 20. And then we write down our 3. And so we end up with 23/5. Now this also works with algebra. What if we had x minus 1 over x? And we need to write that as a single fraction. Well, the x at the beginning is really a fraction over 1. We need our common denominator to be the x. So we're going to multiply this first fraction by x over x. X times x is x squared minus, and then the 1. So we have x squared minus 1 over x. Now we can also break up a fraction. This fraction x squared minus 1 over x, we could break that down into x squared over x minus 1 over x. And then x squared over x, that's just x. And then we copy down our minus 1 over x. That's what we started with. So you can combine two fractions to make one, or you can break one fraction up to make two or more. So let's do one more of these. Let's do 8 minus x over 4. And we're going to write this as the difference of an integer and a fraction. So what we can do is take every term that's on the top and write it as a new fraction over the denominator. So our first term is 8, and we're going to divide that by 4, minus, and then our next term is x, and we're going to divide that by 4. Is there any simplifying we can do? Oh yes, 8 and 4, those are both multiples of 4. 8/4 is actually 2, and then minus x over 4. So we have written 8 minus x over 4 as the difference of an integer and a fraction, 2 minus x over 4. Okay, so now to get to work on some of the problems that are actually in the set. We're going to look first at problem number 4. This is just like problem number 10 in the homework. So after I finish working through problem number 4 here, you should do problem number 10 from the homework. Number 4 says write each of the following as a fraction in simplest terms. It does say simplest terms. That means that you need to go ahead and reduce your fraction as much as possible. So don't leave it in, 12/4. 12/4 is 3. You need to simplify your fraction. Okay, so let's do part A, which is 5 plus 1/8. Okay, 5 is really a fraction over 1. Let me make that look more like a 5. We need a common denominator of 8. So I'm going to multiply this by 8 over 8. So when we start to write our numerator, we start with 8 times 5. That's 40. Plus 1. So we get the fraction 41/8. We're going to jump down to part C, which is 2 3/7. This is the way that you're used to converting mixed fractions to improper fractions. I'm sorry, mixed numbers to improper fractions. We do our whole number, which is 2, multiply it by our denominator, which is 7. That makes 14. We add that to the 3 that was already in our numerator, and then we put our 7 on the bottom. So that is 17/7. And then we'll do just one more part. Let's look at part E. We have 6 minus 1/6. Okay, 6 is really a fraction over 1. We need to multiply this by 6 over 6. And when we do that, our common denominator is 6. We have 6 times 6 is 36, minus 1. So what we end up with here is 35 over 6. Now, number 4 is just like the kind of math problems that you did in 5th or 6th grade math. It's nothing new. They show you this with just regular numbers so that when you do the next problem and we're throwing in x's, it's not going to be such a wild difference. So this was number 4. It's just like number 10 that I assigned as homework. Make sure you remember to put your fraction in simplest terms at the end. If you end up with something that can become an actual integer, go ahead and write the integer. Don't leave 8/4 as an answer. Go ahead and change that to 2. Okay, so the next one we're going to look at is number 5. Number 5 also says write each of the following as a fraction in simplest terms. You have to reduce your fraction. You aren't done if you haven't reduced your fraction. So this is just like number 4, only we have x's thrown in this time. So we're going to do number 5 part C. We have x plus x squared over 3. Now we want the x is a fraction over 1. We need our common denominator to be 3, so we're going to multiply the x by 3 over 3. So we're going to have a common denominator of 3. 3 times x is 3x plus x squared. And we're done. There's nothing else we can do with that. So now we're going to jump down to part F. Part F is 2 minus 3 over x plus 6. This 2 is a fraction over 1. We need to multiply it by x plus 6 over x plus 6. So I'm going to write that down. And then we're going to write that as a fraction with the common denominator of x plus 6. So we need to multiply x plus 6 by 2. The whole thing, x plus 6, has to be multiplied by 2. So x times 2 is 2x. 6 times 2 is 12. And then we're going to subtract the 3, minus 3. So then we need to go ahead and simplify. Our 2x stays the same. And then we're going to have plus 9 because 12 minus 3 is 9. And there's nothing further we can do here. So at this point, we're done. 2x plus 9 over x plus 6. Okay, we're going to do 2 more parts from number 5. Number 5 is just like number 11. So once I finish number 5, you should stop the video and go work number 11. Okay, part I, we have x plus 3 plus 1 over x minus 3. This x plus 3 is really a fraction over 1. We need a common denominator of x minus 3. So I'm going to multiply this by x minus 3 over x minus 3. That's going to give us our common denominator of x minus 3. And what we need to start with is x minus 3 times x plus 3. Now, if you remember and can recognize what the difference of two squares looks like in factored form, we've got the difference of two terms multiplied by the sum of two terms. We have the same x and 3. We're subtracting the x and the 3. We're adding the x and the 3. That's a difference of two squares. So we take our first term and square it, and then we subtract the square of our second term. X squared minus 3 squared. Now we add our 1 that's over here. And so we end up with x squared minus 8, because negative 9 plus 1 is 8, over x minus 3. Okay, the last one we're going to do is part J, and that is x plus y minus 2xy over x plus y. Okay, this x plus y is really a fraction over 1. We need to multiply it by x plus y over x plus y. And then we get a common denominator of x plus y. We need to put these in parentheses, and we can see we have x plus y times x plus y. You may recognize that as a binomial square. When you take the same two terms and you add them together and square the sum, then what you're going to have is the first term squared plus the double of the product of the first and second term plus the last term squared. You can, of course, draw out a grid to work this problem. I have no problem with that. In fact, I encourage you to use the grid to work out these products here, because it will make your life easier, because you'll be more likely to get the right answer. Okay, then we need to subtract this 2xy minus 2xy. So this plus 2xy and the minus 2xy, those cancel out, because those will add to 0. And so what we end up with is x squared plus y squared over x plus y. Okay, so that was number 5. It's just like number 11 that was assigned as homework. And remember, you have to put your fraction in simplest terms at the end. Okay, so we'll start number 6. We will not finish it. Number 6, you're shown two fractions, well, two expressions. We have x plus 2 plus 6 plus x over x minus 3. And then the other expression is x squared over x minus 3. And we're supposed to evaluate this for several different values of x. So I'm going to do this first for 4. We have 4 plus 2 plus 6 plus 4 over 4 minus 3. Well, 4 plus 2 is 6. 6 plus 4 is 10. 4 minus 3 is 1. 6 plus 10, that is 16. And then when we plug it into our other one, we have 4 squared over 4 minus 3. That is 16 over 1, which is 16. So you can see we got the same answer. So we'll continue on with this problem in part 2 video.